right, let's go over domain 3.4, explain the importance of resilience and recovery in security architecture. So in this lesson, we're going to be going over high availability, the different site considerations that we want to think about during our resilience and our recovery, platform and multi-cloud systems, so platform diversity, how we're going to do COOP or continuity of operations, and then also our capacity planning as well. And that's going to be for our infrastructure, for like high throughput of people. And what we mean by that is, do we have peak seasons, right? Then we're going to go into the different ways we can test our resilience, the different ways we want to enable backups, and then also go over something that sometimes slips cybersecurity professionals' minds is the power, right? What I always like to tell my students is that as a cybersecurity professional, you're always thinking logical, technical. It's just the way we are, right? You get into tech, you think you're going to be the guy in the hoodie in the matrix the whole time. But a lot of times, it's the full picture. So as a cybersecurity professional, if you don't have ups at that CEO's desk, or at least thinking about it, or notice he doesn't, maybe you should, right? And especially to our comms closets and our critical infrastructure, we want power backups as well. And we may not be the actual SOC analyst that goes and installs an ups, but we got to think about it, right? Something we have to be aware of when planning our defense in depth, our availability, and our resilience in an infrastructure. Okay, so high availability. High availability refers to systems designed to be operational and accessible for a long duration without interruptions. Essentially, all we're saying is when we plan to deploy any technology to our customers or to our users, whether that's a service, a web application, a feature update, or our data storage, we want to make sure that we have high availability on whatever that data or that feature, that service is. So there's a lot of different ways we can do this. We always like to come back to our three main components of computing, right? Storage, compute, and networking. When you look at a data rack, these are going to be the three major components, right? So the high availability for storage, well, if we're doing that cloud-based, that could be storing and replicating across multiple regions and zones. If this is on-prem, this could be having multiple NetApp clusters, right? And maybe a NetApp cluster in a different region as well, replicating data between those cross regions. When it comes to compute, that can be things like clustering web servers or containerizing and using Kubernetes to elastically scale our services and our features to our customers. For our networking, that could be doing things like NIC teaming, link aggregation, and load balancing, right? Setting up that load balancing and that load balancer to actually handle a lot of network traffic. So what's the importance of this? It's essential for businesses that require a constant online presence and immediate data accessibility. Now, it says essential for businesses that require, but what business doesn't, right? Even if you're in sales, if you're selling turf, the time of speed you get to that customer, it's going to make the sale in today's society, right? In today's world, it's all about speed. It's all about immediate access, right? And that includes all of our systems, from the endpoint to the network infrastructure to the apps that sit in the cloud and the serverless microservice architecture. So load balancing versus clustering. So this is really going over like networking and computing. So load balancing and clustering are methodologies aimed at distributing workloads and computing resources that enhance overall system performance and reliability. Oops, sorry about that. Load balancing. This focuses on the efficient distributing of incoming network or application traffic. So this is just, hey, we have TCP streams coming into our web servers. We have HTTPS traffic coming. But we need to load balance that on the network end, right? Clustering. This involves linking multiple servers or like services, containerization, so they function collectively as a single, more powerful system. This could also be for storage, right? You can make NetApp clusters as well with all your disks, okay? So load balancing aims to optimize resource use and maximize system throughput, the network side. Clustering is primarily geared towards maximizing system availability, your compute availability, right? Making sure that the processing power is enough for you to do whatever function that server or service needs to do. Site considerations. So now we're talking about like our continuity of operations here. If we have a data center that our users, our customers, our enterprise relies on, and it's just a single data center, now we have to start thinking about our redundancy, our resilience. So when we start considering an additional site to add in to make sure we don't have a single point of failure, we have 3 different methods of site considerations we're going to talk about: hot, warm, and cold. The first one we're going to talk about is a hot site. So this is going to be an external facility, and this is just an umbrella term, right? Whether it's just a single comms closet, a whole data center, a region in the west, and then a region in the east as your hot site. It's just an external facility that is fully equipped and operational, currently operational, to take over business operations immediately. So the point of a hot site is to have immediate services, right? To have services up immediately. You plan for 99.99% uptime. So if you're planning for that uptime, that means if your primary goes down, the redundant, the backup, the standby should immediately come up within microseconds or seconds. Now, obviously, if you're talking about a full suite of services in a data center, sometimes it's not always this clear, right? It could be that we have a hot site, but for some of our critically essential services, we want to fine tune those. And then the other things that maybe are not essential, they come up in time, right? We're not worried about the microseconds. So hot sites are operational around the clock with minimal or no downtime in the event of a disaster. Operating a hot site obviously is going to be, it's going to cost the most, right? Because you're just managing 2 different data centers at that point, right? You're managing your primary and standby, but they both need to be life cycled. They both need to be replicating, and they both need to be up and operational. So obviously it's not the most cost efficient. This is going to be taken into consideration when you go over the risk appetite in the organization. So essentially, if we care about having strong cyber resilience, and we care about uptime as the most important thing, we'll invest in hot sites. A warm site. So a warm site provides a middle ground between a hot and cold site. It's equipped with some, but not all the components necessary for swift activation. So what we're saying here is that warm sites, you're probably going to have the data center racks. You're going to have the equipment. They're going to be powered on. They may have internet connectivity, but maybe they're not fully functioning, right? They're not currently doing any data processing. They're just waiting for that primary to go down, for an administrator to come in, do the full configuration. It could take anywhere from an hour, 2 hours to maybe a day, right? And then it's up and operational. So the cost, it's kind of a balancing act, because you may just have the equipment there powered up, but you're not really worried about the life cycle. Maybe some of them are legacy. You're not, if you're worried about operational costs, they're not turned on. You're talking about the cloud, right? These may be VMs that are just sitting in a standby mode that'll take an hour to come up, that are not taking up that monthly cost, right? So it's lower than a hot site. It's higher than a cold site, but it's kind of that middle ground, right? It's a way for us to have redundancy within an allotted period of time. That's not going to be weeks or months, okay? A cold site. So a cold site is a backup facility that provides space and infrastructure, but does not have the hardware and software installed and configured for immediate use. So imagine a cold site. This is just, hey, we rent this data center rack, and if we ever come hard down, our plan is to go in and do a full reconfiguration. Why anyone would want to do this, I really don't know. Essentially, you're just paying for empty space, but that's what a cold site is. So this is suitable for organizations that can afford some downtime and want a cost-effective disaster recovery solution. Maybe this is just an organization that says, hey, we don't plan for our primary to go down. Like, we made it resilient. Maybe we do some hybrid. If our on-prem stuff goes down, it's not our customers are going to be affected, maybe just some of our employees, and we're okay with that, right? Because maybe whatever our e-commerce function is sitting off in the cloud, so our on-prem data center, our on-prem services can take a 24-hour to 48-hour to 96-hour hit, right, to become fully back operational. So we invest in a cold site. Some other site considerations: geographic dispersion. So geographic dispersion involves spreading IT resources, operations, and sites over diverse geographic locations. Why do we do this? A lot of it has to do with risk mitigation, right? Think about not just the data sovereignty, not just compliance. That's something we do have to think about. But think if you host a data center in Florida. Now, anyone that's worked on soft before, we know every hurricane season, there's going to be a coup, because guess what? The data center comes down. Power goes down. It's a hurricane season, right? So imagine if people that run data centers in Florida put a secondary data center in Miami, right? So they're in Tampa, they put a secondary one in Miami. Is that good geographic dispersion? Probably not. I mean, it is far enough away, maybe, but you don't want that, right? You want solid geographic dispersion away from natural disasters if your primary is in a natural disaster zone. Another thing we have to be aware of is just compliance. Of course, if we plan to do a redundant data center, maybe a hot site in Europe, well, that's going to take extra configuration because we have to worry about their compliance and their rules over there and their laws like the GDPR. Platform diversity. So some cybersecurity and IT experts think that to have true diversity, you need to be platform agnostic, meaning that we understand to do Active Directory, you have to have Windows. But maybe for some other services, you deploy Red Hat Linux. And why would we want to do that? One, let's think about vulnerabilities. Let's say you have just a flat Windows organization where everything's Windows, Windows Server 2022, Windows Azure services, everything. That's fine. It probably makes it a lot easier for your technical side, right? Because you're just using one platform. Well, what if there's a vulnerability that affects Microsoft systems? Then everything's vulnerable. So maybe you want that platform diversity to do some risk reduction. Maybe you want some vendor independence as well. Relying on a single vendor can get a little dicey. Sometimes people, like in their network infrastructure, they'll have Palo Alto firewalls, they'll have Cisco routers, Cisco switches, but then they have Aruba wireless access points. That's something I've seen before. Now, very difficult for net engineers, right? Especially when they want to start doing like software-defined networking, and now they have to learn network automation instead, right? To do that infrastructure as code, centralized kind of platform. But you have vendor independence. You have better flexibility. It provides more options for backup recovery and performance optimization. Multi-cloud systems. So a lot of organizations now, especially with the introduction of IAC, like languages like Terraform, where we have cloud diversity, where we say, hey, we're going to deploy microservices on AWS. We're going to deploy compute and storage resources on Google Cloud. And then we're going to do Azure Active Directory. And then we're all going to connect them using their different networking capabilities. And we're going to configure all this from a single platform using Terraform, because that can interact with all these different clouds. So multi-cloud systems involve leveraging cloud services from multiple providers, thereby avoiding dependence on a single vendor, okay? Again, this is just maybe as an organization, if you feel more comfortable, your risk appetite's high, so you say, or it's low, excuse me, it's very low, so you say, hey, we don't want to rely on the AWS East region for everything. That went down 4 years ago. Maybe we want to put some critical services in AWS and Azure. Continuity of operations. So continuity of operations is the practice of ensuring that essential business processes can continue during and after a severe disruption. This is high level, right? This is not you actually configuring a hot standby recovery protocol. This isn't you putting that F5 load balancer on the network. What we're talking about here is our overall planning and architecture to have continuity of operations. So this could be as simple as you in the SOC and the NOC listing, doing your business impact analysis, doing your asset inventory, and noticing single points of failures that are going to be critical for our customers and our users. And now you go and plan resilience. Now you go and plan that. This could be also you testing your coops, doing your testing exercises, failing over to your weaker transport, right? So if you have Starlink as a secondary form of transport and you have a dedicated business line, cut that business line during an ASI window, a service interruption window, and test to make sure services still come up using that second form of transport, right? So testing and exercises are essential to validate your continuity of operations. This could also be at the human level as well. Do the stakeholders in all of our different departments understand their role during a coup or during a training exercise or during an outage or during disaster recovery? Capacity planning. So capacity planning involves the process of determining the necessary resources to meet future workload demands while maintaining a balance between cost and availability of resources. But what we're saying here is that as an organization, do we understand our peaks? Do we understand how we have to scale and how elastic we have to be to ensure we don't have downtime? So a great a great example of this is really any streaming service, right? When they're expecting a popular show on their platform to have a lot of traffic, do they have the proper capacity planning? Most organizations don't, because those rare spikes cost a lot of money to plan for, right? So like in this example, a popular show or anime One Piece came out with a new reveal, and the servers crashed when that reveal came out, or that new episode came out. So as a cybersecurity professional, that could be seen as like, a failure on the team there. But again, you just don't know exactly what your peak is until it happens. So during that outage, because of high throughput, that's where we can do our root cause analysis, do our lessons learned, and now backwards plan for that next time it happens and increase our capacity, or at least find a way to make it scalable. Okay, let's go ahead and do our check on learning. Okay, so question 1. What is the primary advantage of geographic dispersion in protecting an organization's data? So A, cost reduction. No, it's going to cost us more. Compliance with local regulations. I wouldn't say it's an advantage, something you have to worry about. It could reduce our latency depending on where our users sit. But I think the primary thing the primary advantage is going to be protection against site-specific disasters. So like we talked about, if you have data centers where earthquakes routinely happen, well, that's not very good planning, right? Question 2, which statement accurately distinguishes load balancing from clustering in terms of high availability? That's going to be A. Load balancing distributes traffic among servers, while clustering involves connecting multiple servers for a single application. Clustering web servers, containers. Question 3. How does platform diversity within multi-cloud systems enhance security? So we're going to go with C here. By avoiding reliance on a single provider, thereby reducing the risk of simultaneous failure. Question 4. Which aspect is crucial in capacity planning to ensure continuity of operations? So that's going to be planning for future growth and traffic spikes, right? We got to plan for that that increase of users, resources, of anything. Question 5. Which factor is most critical to ensuring the continuity of operations during a disaster? So no matter what we do, guys, it always comes down to the human element, right? We can place any technology, any system, we can write any sort of automation scripts we want, but having the stakeholders understand their role is always going to be the most important thing during disaster recovery and our continuity of operations. All right, question 6. Which of the following disaster recovery sites is fully equipped and ready to take over operations immediately after a disaster? That's going to be a hot site, right? A hot site is something that's already up and operational, so it can quickly take over.